All right, let's talk about our 9.3 assignment, which has to do with just lots of different definitions. And so the first thing we're doing is just drawing angles. And you really need to label your axis starting at 0 and remembering that the axis is labeled from Algebra 1 with the fact that, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So knowing that, we understand how we go 0, 90, 180, 270, 360. If I did negative, it would go in the other direction. It'd be negative 90, negative 180, negative 270, negative 360. So to draw 128, for instance, you just approximate it between 0 and 180 and just show the rotation in the positive direction, which is counterclockwise. Now, when you do pies, it's a very similar thing, right? So to do a pi axis, remember that we're actually drawing a circle, and the circumference of a circle is 2 pi. So this would be pi. This would be pi over 2, because it's half of 2 pi is pi. Half of pi is pi over 2. If I add these together, I get 1.5, which is 3 pi over 2. And then I would draw it in here. But if you're going negative, it would be 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So to graph negative 3/4, I just graph it between negative 1/2 and negative 1, and I show the direction in the clockwise rotation, which is actually negative. Okay, so coterminals. Coterminals are simple. You add 360 or subtract 360. So 120 plus 360 is 480. 120 minus 360 is 240. Just keep in mind that if I did this problem like this and I added two 360s, this would also be coterminal. I mean, you could tell me the coterminal is 840. Or you could tell me the coterminal is negative 600. You can do it again just for fun, right? So that's also coterminal if I were to subtract negative 360, okay? So to do it with pies, you really got to be careful. You got to learn how to do fractions a little bit more. 7/9 plus 2 pi, you really want to add 18/9 because 18/9 is 2. If I was doing 6, I'd do 12 pi over 2. If I did 8, I'd do 16 pi over 2 because all of those are 2. 7 plus 18 is 25. 7 minus 18 is negative 11. So then we're doing reference angles. And reference angles, it's really important to understand that if you don't graph, reference angles are confusing. So graph 250 by graphing it between 180 and 270, and then ask yourself, how far apart is 180 to here? You always go to your reference angle is to the x-axis. So the closest x-axis is 180. And 70 degrees is how far it takes to get to 250. You just simply subtract these. And if it's negative, take the absolute value. Now, in the world of trig, right, in the world of radians, I did pi over 2, pi, 3 pi over 2, and 2 pi. And 10/7, the way I graphed that was 10/7 is about 1.4. So I graphed it right next to 3/2, which is 1.5. And to find this theta for this reference angle, I just turned the pi into a corresponding, number that matches the denominator. So 7 over 7 is 1. So how far apart is 7 from 10? 3 pi over 7. This one I would use 5 over 5. This one I would use whatever I need to. Keep in mind that if I was over at 2 pi, which is what you do for this one, you would use 12 pi over or whatever to get to that value. All right, so to find coterminal angles and you sketch them, you need to find something that's between 0 and 360 to sketch it. So when I start off with the first one, it's pretty easy to realize that 390, I'm actually going to sketch instead 30, right? Now to do 1125, I really got to play with it, right? 1125, I subtract 360, not there. If I subtract 360, not there. If I subtract 360 again, I'm at 45. So I actually drew this at a 45-degree reference angle. And then I showed each one of these 360s as a spiral. 1 spiral, 2 spiral, 3 spiral, stop at 45. The conversion's pretty easy. Conversion, you multiply by the conversion factor of pi over 180, and then you take out a GCF. So the GCF that is in here is 6 degrees. So I yank 6 degrees out of 180 degrees, leaving me with 30. I cross it out. I have negative pi over 30. To do it with pies, I reciprocate this, and I do 180 over pi. I yank out the fact that there's a 12 in here, so the pi cancels in the 12, leaving me with negative 15 degrees. If you do it that way, you do not need a calculator. Keep in mind that there aren't calculators on upper-level AP math tests for most of the test. All right, so here we have a little game I like to play before we do the end of it, which is how do I know what quadrant things are in? And so the way you know what quadrant things are in is there's this little mnemonic device, which works like this. All things in trig are positive here. Only sine is positive in trig here. only tangent is positive here, and cosine is here. All students take calculus, the point of taking this class right now. So if you use this mnemonic device, look what it says. It says sine is positive, right? Because greater than 0 means positive. So if it says that sine is positive, I'm going to go ahead and box these two quadrants in because all things in, then we have sine. Then it says that cosine is negative, which would then get rid of this quadrant because all things are positive, leaving me with the answer quadrant 2. Now, some people do not like that, and so the other way to do it, which takes a little longer but maybe makes it simpler, is to realize that these quadrants are really, from Algebra 1, this is the positive positive, this is the negative positive, this is the negative negative. I'm talking about x and y here, and this is the positive negative. Well, the x and y in trig become sine and cosine. So it's alphabetical, cosine then sine, cosine then sine, cosine then sine, cosine then sine. Now watch what you do. Sine is positive, so it's got to be this one or this one. And then cosine is negative. So hey, look, cosine is negative here, so it's quadrant 2. Now, if you do that, right, if you do that with cosecant, please remember that cosecant is not really a thing that people calculate with. They instead cross that out and say, thanks a lot, but I'm going to use sine for cosecant and cosine for secant. So that really says cosine is negative and tangent is negative. So again, if you use the mnemonic device, all students take calculus. This is asking where everything is negative, so it's kind of interesting, right? So can't be this one because that's where sine is positive. Can't be this one because that's where tangent's positive, and it can't be this one because everything is positive, so it must be quadrant 4. And if you do it the other way, where you do it with this, it also works just as fine. And it doesn't really matter which way you do it. I like to show both versions because some teachers only do it one way versus the other. It's up to them, right? So cosine sine, cosine sine, cosine sine, cosine sine. And so you're looking for sine to be negative, right? So you're looking for sine to be, I wrote that one down wrong. My apologies. That one is plus minus. So when you use that one, that is the weakness. If you kind of like have a moment where you aren't paying attention and you mess up, right? So that one is positive, negative. So we need a quadrant in which sine is negative, which would be here, right? And it would be here. But then tangent is negative when you have a mixed match of signs. So tangent is y over x or sine over cosine. And so when these two mix match, tangent is negative, so it still would be quadrant 4. Okay, so why all this talk about quadrants? Okay, here is the reason. If I take a look at this problem is kind of interesting because of the fact that when I look at it, right, it really comes down to knowing this negative positive thing. Let me explain what I mean. So when I draw this, I have to draw this as what I like to call a bow tie angle. I have to draw it on the x-axis as one of these angles. It forms a bow tie. I could never, ever draw it on the y-axis. This is not a thing ever. So when I draw this, it does tell me quadrant 2. That's helpful because it tells me that cosine and sine are negative for cosine and positive for sine. So when I draw this triangle, I'm going to draw it reference to the x-axis here. And I remember that sine is y over r, so I'm going to put the 7 on the y coordinated axis and the r, the 8 here, and then my job is clearly to find this, right? So I'm going to use x squared plus y squared is equal to r squared. In this case, what happens is the x is the unknown, right? The y is 7. The 8 is the hypotenuse or the radius. So I get x squared plus 49 is equal to 64. I subtract 49 on both sides and I get 15. And then I take the square root. Maybe I've been wondering, like, where's the plus or minus been in trig? Well, here it is. It's actually plus or minus, meaning literally choose positive or negative. That's why this thing is so important. It says that cosine is negative. So I've got to put negative root 15 here. It makes sense, understanding that cosine is x. This is the x-axis. That's a negative value. It's going to the left. So when you come over here and actually write down what cosine is, right, remember that cosine is equal to x over r. If you ever get confused, it's alphabetical. Cosine is x, sine is y. So the x value in this problem is negative root 15, not positive, and then divided by r, which is 8. You know that's tricky because on a test, both positive and negative would be in there, because that's the whole point of 9.3 is to learn about negative and positive rotations and angles, and in this case, cosine and sine values. So sometimes they actually play the quadrant game with you in the problem. So watch how this one works. It's kind of fun. So here what happens is we start off with an axis, and they ask me to label it in the pi version. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then what happens is we arc this, given this is basically saying it's subtended from 0 to pi. So we're talking immediately now about quadrant 1 and 2. Then it gives us secant. And I want you to understand this about secant. Nobody calculates with secant. It does eventually turn into an important, meaningful graph later in trig when you learn how to graph. But secant of -3 really means that cosine of theta is equal to -1/3. And that's how you're going to build your triangle, right? So it's in this quadrant because cosine is negative. And again, all students take calculus. It would have to be, right? Or you just do, you want to, you can do it like that and label it cosine sine. And so the -1, remember cosine is really x over r, so this would be -1, this would be 3. Time to do the new Pythagorean theorem thing that we've been talking about, x squared plus y squared equals r squared. By the way, that is the equation of a circle. Just let you know, it all comes in and is used for other things. So this would be this, giving us 1 plus y squared equals 9. Subtract the 1 on both sides. You get 8, take the square root with the plus or minus, and you actually end up getting plus or minus 2 root 2. Don't forget about reducing your roots. So the question is, why is it positive or negative? Well, y is here, sine is positive, so this would be positive 2 root 2. So then when it comes over here and asks me, hey, could you find sine? Sine is y over r, so sine of theta is y over r. I look at my diagram, sine of theta would be 2 root 2 over 3. A lot of repetitive stuff with tricky pluses and minuses. That's a good way to describe what we're doing now. Hope this helps.